Welcome to week 5 of the Magic Academy sessions. Um, Last week, I was out hacking on some WebXR projects with some people, and we had Parzival fill in and I think do kind of a QA session and go over some stuff with some people. Very helpful. And before that, we went over a lot of the really important high level kind of concepts and value propositions of what we're bringing here with, embeddings, events, documents, um, obviously all the AI stuff. But we haven't really covered some of the more basic things in Magic. Like, if you come to this context menu and you see all of these different options, some of them make a lot of sense and are pretty obvious, like search Google, you know. Um, we have a cool new one called Current Time. Very useful. I think you can pretty much figure that out. But a lot of the stuff in here is pretty complicated. And if you're not from a programming background, it might be totally foreign to you. Um, Especially things like you hear a word string, Boolean, array. These are basic types. And in a programming class, they're usually the things that they'll start to teach you in the first few weeks. But we've kind of worked backwards from why is this important? Like, what are we building to, okay, now you're probably in the weeds a bit, wondering, how to solve small problems. How do I have just add like a slash command to my character so that it doesn't have to like always go through the whole AI process just to like do a simple thing. Or how do I maybe have like two different cases where like if it detects this kind of thing, it does this, and if it detects that kind of thing, it does that. And so we're gonna cover especially the areas of what strings and text are, and what all of these nodes here do. And then we're going to talk about Boolean logic, what Booleans are, and control flow. And control flow is, well, we have these kind of purple sockets, and these are our trigger sockets. And what the trigger sockets do, you can see in this very basic example, is, well, it makes sure that the control, like what is actually being run, what node is saying, hey, do your thing that you do, is this purple socket, this trigger socket. And once this does its thing, passes it here, this does its thing, passes it along. But actually, you can have branches. You could do something wild, like, you could trigger this too, right? And now you've got two echoes happening, and maybe you have two outputs. And so now you're going to have to start thinking about, well, how do you decide which one you use? How do you make sure they both happen before you then go back to whatever the next thing here is? And that's all control flow. So at the core, Magic is it inherits from a long line of flow-based programming languages and visual node editors. Those are kind of the two broad terms that describe the sort of thing that we have here. This is not a new paradigm. It's actually a very old paradigm. And there have been node editors like this for a very long time, since the 70s, that did this kind of control flow. But Magic is the first time that we've really applied this to AI and used it to really, obviously as a way to manage our vector stores and large language models and whatnot. So I've posted some lecture notes for everything we're going to go over here in the Academy repo for obviously week 5. And we're just going to go through this, and I'm going to show you some of the notes, and we're going to talk about a few concepts. So the first concept we're going to talk about is strings, right? Well, what is a string? Oh, okay. So we know like a string of pearls, right? A string of things. It's usually like one thing after another. The etymology of the word is a sequence, right? And in code, what it comes from is a string of characters. And so then the question would be, well, what is a character? So first, we should talk about characters. A character is anything you press on your keyboard. It could be a K. It could be a weird, curly brace. It could be a plus. It could be a capital A or a lowercase a. It could be some kind of weird, Greek alphabet. And all of these are encoded. Basically, we have to turn them into numbers underneath in the computer. But we represent them as symbols we understand. So each symbol equals a character. Each one of these is one character, and a string in programming is a collection of characters. And that string can be any length. So I could say, the quick brown dog, or whatever. The quick brown fox, I think that's what it is. And the quick brown fox is a string. I think string is a really cumbersome word. Once you understand in your head what a string is, you can just kind of replace it with text. Like any amount of text. It could be an entire, it could be the entire Bible. It could be a couple of letters. It could even just be one letter. A string could just have one character. It's just one string length character. In old programming languages, characters and strings are very different because the way that we stored them in the computer was very different. And so there was all these different kinds of ways to help you. But in modern stuff, especially in the languages we use, which are Python and JavaScript, there's no difference. They're stored the same way. So long story short, string equals text. If you see the word string, what you should think is that's going to be some text. It's not data. It's not a number. It's not like, some uninterpretable thing that the computer knows and you don't. It's stuff that you could probably print out and read. So a lot of what we do inside of Magic is working with different kinds of text. You can see that sometimes you'll see this word string. I think we're going to try and actually replace all of the instances of string just with text because it's just a little more simple. But string equals text. These orange sockets are currently string sockets or text sockets. That means that you can take anything you write here and put it in. Great. So let's start with the two kind of main variables that we have here that affect that. We have the string variable and the text variable. The output of the string variable and the text variable is the same. The only difference is kind of how we represent the text. And honestly, we might just get rid of the string variable because, I don't know, if people like it, we'll keep it. But the text variable seems to be a little more effective for actually writing most things. So the string variable is like, what do I usually use a string variable for? Well, let's say I want my agent name. And I'll give this string variable the agent name. I can make it public so I can access it, in the agent view. And I can give it the value, like a default value of, Eliza. Because that's the character we're kind of working on. Cool, right? Makes sense. The output of this will be Eliza. We've seen that before. Now, if I go to this text variable and I go here, I will call this agent name text. And I'll make it public. And I'll type in here, Eliza, and I'll save it. And the output of this is also going to be just the text, Eliza. Make sense? They're basically the same. So with that text, I can do all kinds of things. And maybe we'll try a few of them. The first thing I'm going to do, let me make sure we kind of got through this. Yeah, cool. The first thing we're going to talk about is a profanity filter. So there's kind of two ways to do moderation, and you're going to probably want to do moderation to some degree on your bots. You don't really want people to abuse them, especially if you're doing things like educational applications. You might want some basic filtering. And this kind of comes in two flavors. There's the cheap flavor, which is very basically just doing string matching, or basically matching, does this contain certain text? And then there's the expensive flavor, which is using like a large language model moderation API. So OpenAI and soon Google, for example, offer an API which basically tells you, is this dirty or not? And it gives you a few different scores, like is it violent, is it sexual, is it inappropriate for these different reasons, racist or whatever, and then you can make decisions with that. But the problem is you have to pay for the moderation API, and it takes an API call. So sometimes you want to kind of do something cheap first, right? Just if I say a bad word, or I say like, hey, what do you think about Nazis? You might just want to like say, hey, I don't talk about Nazis. Like, it's not what we're here to do. I'm a clone of Carl Sagan. I want to talk about cosmos. I don't want to, that's not, you're probably trying to be abusive. And so the profanity filter is here to uh, basically analyze against a collection of different words that it has and figure out if whatever came in has something bad in it. So a lot of times I'll put this on the front of whatever input if I'm doing something where I care about that. And that way, just like I can have a really shortcut for anything that's dirty to be like, hey, don't you know, sorry, I can't respond to that request or whatever, something like that. What are the bad words for the profanity filter? Well, I have made a repo called expletives where I farmed, I guess I mined out some really bad words from elsewhere and created some functions to find some particularly offensive things that, and variations on it that people might say. And we are installing this package and using it. Now it has one kind of downside, which is called the Scunthorpe problem. And I think this is interesting, just to be aware of in general when you're working with text, not just for this filter, but to be aware of. So the problem with Scunthorpe, it's a place in England, is that it has a subword in it, which is blocked by a lot of profanity filters. And so a lot of people doing this early spam filtering, search engine filtering kind of stuff ran into this issue where they would become too restrictive by trying to get rid of certain words. Like, for example, somebody doing shitakemushrooms.com, you could imagine the problems there. And so basically building text matching algorithms has this, there's sort of a math equation for like the more false positives you get based on the more expletives you add. So one of the problems we have is like currently we're blocking the word kill, which is great, but I'm really trying to work on something with skill handling, and I need the word skill to be triggered there. So we will be going through and probably lessening this or creating kind of like this is definitely dirty, like a few different cases, but just to be aware of. That's something, that will might help you. Okay, the combined text. I'm not gonna show this one, but I'm gonna show most of these because I think that would be helpful. So the combined text node. Well, instead of bringing that down, I'll actually just create it in place. What we want to do is we want to. Sometimes we can use the text template. I showed that in a previous episode of this thing, but oftentimes we're going to want to just do like a simple like combine these two things together very easily. Okay, so let's say I have input, and then I want to add the time to the end of it. I want to have whatever I say, I want it to respond with an echo, but I also want it to have the time. I have this new current time node. Very useful for giving your agent a sense of what time it is. So I'm going to drive the trigger into the current time, and then I will drive that into our destructure like that. Now, I need to combine my input with my current time. Okay, so let's go down to text and let us go to combine text. So the combined text has an input socket here, and we can give it as many input sockets as we want, and they're going to be added together, and we can put something in between them so that they're not just jammed together. We definitely want a time socket, and we want, we want a content socket, and we want a time socket. Cool. And then let's have a delimiter, and let's make the delimiter just like a little pipe like that, right? Cool. Now we can take the trigger and trigger it in and get our time and get our content. And hopefully, let me just save that. You can see that it responded with our time and our content, right? Not so bad. Now I'm a little curious as to why I did it that direction. I'll think about that. Yeah, so generally we use this to combine stuff. we should probably have a direction here, but anyway. It clearly, it concatenated the time onto the testing, and it used the delimiter here to divide them. I wrote in testing, and it gave us back the time plus testing. So that's how we can do a basic, quick combined text. However, I feel like this is a great simple node, but it doesn't really give me as much control as I would like. Usually I have to do more complex templating or combinations. What's nice about this is that, it's quick and it's simple, but usually I'm going to reach for my text template node. So if I go in here, go to text template, this basically does the same kind of thing, but in a much more dynamic way. So I'll take in time and content, and then I can write something like, you said content at the time. We talked about this a little bit in the last session. This is called handlebars notation. You see that it has two little curlies on both sides. And as long as you have an input here that is named exactly the same in your inputs that we just created, these sockets, as it is in this handlebars notation, it will replace that in your template with the appropriate text, right? So I can go here to current time and grab that, and I can grab content, and then I'll trigger that, and we'll output that to our node. We don't even really need our echo node. That's just a utility node. It doesn't do anything. It's just kind of a, an empty pass-through to make sure things are working. So we can just go directly from our text template to our output. And then I'm just going to refresh really quick. Ooh, something happened. Strange. Let me just rewire that. This is time, content, trigger. The prompt goes out, and output goes there. If I save it, does it? Okay, great. Something happened. Lost my wires, but there we go. So if I type in testing, you can see it says you said testing at the time 5/3/2023 at 1:49. Great. This text template obviously took in the content, took in the time, combined it together, and then output it. So this is like one of the most useful nodes. I use this all the time for all kinds of like formatting and flow. I can bring the conversation in or different examples or inject a document. This is an incredibly useful node, and probably what you're going to reach for when you have different, bits of information and you want to put them together into like a template. You could imagine something like name, agent name, personality, and previous thoughts. You go totally nuts, and you could process these pieces in some other template or some other, part of this, and then combine them together in the text template. Very, very useful. Of course, you'd have to make sure that it lines up with the input sockets. Cool. I'm gonna do that. So another thing we want to do is we want to, this is going to get into control flow, so we'll bring that over here and talk about that in a second. Sometimes we want to replace text. I'm working on a thing right now. I'd say that let's actually do two parts. We'll do the replace text, and I'll show you the rule matching. So let's say I have, I'll just create a replace text. You said testing at the time. That's all good. Let's make a replace text node. So let's say it's looking for the word, I don't know, testing. I use that obviously. I want to match the word testing and replace it with sandwich. I'm kind of feeling hungry. I think, thinking sandwiches. So let me just refresh that, make sure it's all good. Now, if I type in testing, it now says you said sandwich at the time 5-3. If I say well, it doesn't replace that with sandwich. It only replaces testing with sandwich. So the way the replace text works is you match. Matching is a programming concept, but I think you can kind of get the idea from other games and things. If this is that and they're the same, then replace it with this. Match anything testing, replace it with sandwich. And these could be anything you want. Another thing is that I typed these in, but you don't have to type them in. These could also be dynamically applied. So I could get rid of match there. I could just replace all content with sandwich forever, right? And then I could say testing, and no matter what I do, it's always going to be sandwich now, because it's actually getting the match information is now the content that came in. It's matching whatever I said and then replacing it with sandwich. That's kind of maybe useful. A thing that might be really useful is if I grab like a text variable, I type in like /feed, and maybe I'll match that. I mean, there's a lot of different ways to do this, but let's say, and then I'm saying like /feed berries. Like, let's say I'm feeding my pet, right? Whoa, I just did something crazy. I think it replaced all of them. Fascinating. I don't know what happened there. Probably didn't save here. But the idea is that if I had like a / command or something that I was doing, like /feed, I might want to get rid of that out of my content and just take like the berries, right? So I could, do /feed berries, and then you could say you said sandwich berries. Let's do let me say you ate some content on time. So I say /feed berries, and it says you ate some sandwich berries. Where's this sandwich coming from? Oh, right. Delicious. I don't know. We don't even need to replace it. We can just replace it with nothing. We'll just remove it. Sorry, this is not. Let me explain this a little bit. In this case, what I'm doing is I'm taking /feed, and I'm actually replacing it with empty. That way, if I say /feed berries, you ate some berries, right? It got rid of the /feed. It just took whatever, and I could say like /feed a delicious apple. You ate some delicious. Okay, well, it's not perfect English, but you get the idea. You ate. Maybe I could even just get rid of some. There we go. You ate a delicious apple, right? Super useful for making like little digital pets, or maybe you want some like debug commands that skip, but then you want to like take the rest of the information. You can do this replace text. Very useful. Okay. Where are we? We've gotten replace. We should probably do evaluate text. So now we're getting into control flow. We kind of combined, we replaced, but now we want to make some decisions on text. We want to sometimes say, well, if this happens, do this. Otherwise, don't do that. A very useful case of this would be the digital pet, right? I do this for debugging as well, or commands. But let's just say we have like a digital pet that we want to feed. Okay, I'm going to match the beginning, match /feed. And if /feed is matched, I want to output delicious. How could I do that? I could do an echo node, and I could say delicious in a text variable here. I'll pass that into my echo node. So if we match /feed true, echo to this output. Otherwise, if false, it does not match, echo I'm hungry. And then we can output that as well. We'll see what happens. Okay, it failed. Why did it fail? It might be because of something like that. No, I think we might just be having an issue with this node. Let's see. Okay, well, I think I found a bug, which is, yeah. So the way it's supposed to work, and I'll make sure we get this fixed right after this call, is that if I match the beginning here of /feed, then I would say /feed berries, and it would go hit this delicious. But it seems to be going false for all of them. Not sure why. But the idea of the rule matcher is that if it matches any of the beginning, like if /feed is the beginning, then you will echo true. Otherwise, you'll echo false. But we found a bug. We'll have to fix that. I wonder if it's something stupid like that. No, it just doesn't work. That's okay. So that's one way to do rule matching. But the other way to do it, which is not a whole lot better, is evaluate text. So the way evaluate text works is we give it an operation type, and we tell it what if it equals or includes or whatever that is. So we're gonna make this a dropdown so that you can just select the operation type. Right now, that's just you have to type it in. It's not very pretty. If you click on help, you'll see that we have the options to include, not include, equals, starts with. We're gonna grab starts with, and we're gonna say we want this operation to be starts with, and we want it to start with /feed. So the evaluate text node says, make an operation type. It should start with this, and then this is the text to evaluate it on. We trigger in, and we say, well, if it evaluates true, and if it evaluates false. And hopefully it works. Let's make sure we refresh. Does not seem to be working either. Okay, great. Well, we're going to have to fix that node as well, because it's just going false the whole time. But that's how it works. Assume that we're gonna jump on this after this call and make sure these nodes are working. So in your project, you take a prompt. Oh, you know what would be really important? I just realized the stupidest thing. Sometimes I think things aren't working and maybe they are, which is we actually want to evaluate the text that's coming in, and we might not be. Let's see. There we go. Okay, I was wrong. So when I'm a noob. I took the prompt from the template, which we actually transformed. And I actually need to take the content that came in from here, because then it will be right? So I should probably get rid of that. All right, now we're cooking. Okay, so you can see we have delicious, I'm hungry. If the evaluated text evaluates /feed at the beginning, because we have the starts with operation, then trigger true, otherwise trigger false. And likewise, if I use the text rule matcher here, and we match the beginning /feed, then it should evaluate to true or false. And let me refresh. And if I type testing, I'm hungry. If I type /feed banana, delicious, because the rule matcher matched that at the beginning it it had /feed, which we wrote, therefore it echoed. Now we have some other options here. We can invalidate the beginning as well. How about well, I'm not too worried about that. I'm actually worried about, let's say we want to invalidate anywhere in here. If we feed it a tire, it's probably not going to like that, right? So we can then say, well, /feed tire, and you can see it's actually I'm hungry. It's invalidated. I can slash feed banana and it says delicious, but when I slash feed tire, it's like, no, I'm hungry. I don't want that. The minimum and maximum string lengths would be something like counting. Like, okay, well, if it, this is 1, 2, 3, 4, 5 for this slash feed, plus a space, plus 2. Maybe the minimum string length has to be like 8, or it's not valid, right? And maybe the maximum string length should be like 1,000. I don't know, whatever. And then if I say slash feed A, well, now it's invalidated because you can't feed A. But I could slash feed apple, delicious. So the minimum string length says if it's too short, don't use it. This is also very useful if you're trying to like just catch if people are saying, hey, what's up? Hello, okay. You can kind of use this as a shortcut, those kinds of things. So the text rule matcher can match things at the beginning, the end, or anywhere, and it can invalidate things. So it can, if it sees the word tire, it invalidates it. I could also have like tree. I don't know. Can't feed it tree, right? Slash feed tire, slash feed tree. Nope. But slash feed banana. Delicious. Hope that makes sense. Thanks, Nara, for pointing out my bug. I see that you wrote it, but I did not see it in the chat. It was just in the graph. Okay, so I hope that kind of makes sense with the rule matching and the text templating. What I want to get into is what these true and false mean. I think that sometimes it's pretty... let's talk about logic. Let's talk about George Boole. There's this guy named Boole, and he was a brilliant mathematician and philosopher, and thought a lot about a lot of things. And he especially thought of this thing of Boolean algebra, which is that many expressions, many ideas, could be evaluated to true or false. So remember before, like, you might have like A plus B equals C, right? But like, what if A equals B, or A does not equal B, right? Those are your cases. It's not a continuous, like, well, it could be 300, or it could be 5,000, or it could be 0.4. No, it's either true or false. And if you think about, like, logical deduction in the world, a lot of things evaluate to true or false. The earth is flat equals, well, obviously that's true. Just kidding. The sky is blue. Maybe? True enough, right? We can evaluate it to true. So a lot of things in computers reduce to, did the person do this? Yes, they did. True. Or no, they did not. False. Did we send a request and did it work? Yes. True. No, it failed. False. Cool. So we should also talk about something called equivalency a little bit. In computers, we have 0 and 1. And 0 and 1 very conveniently map to 0 equals false and 1 equals true. And you can also have very complex, like 0011, which might equal like, 32704 or something like that. I don't know, whatever. But generally, when you think of true and false, it's just 0 and 1 equals true and false. And in some languages, if you return 0 as a number, you can turn that into false. It's called casting. 0 equals false. 1 equals true. So this we'll touch on in just a second here and bring it back to magic. We have this idea of the Boolean. And Boolean has a variable. It's a variable type. Kind of like how we had a string variable, we have a text variable, we have a number variable. We also have a Boolean variable. And it can only be one of two values, which are false or true. Now, maybe we want to have something like block profanity, and we want that to be true. And we want it to be public so that some of you people could maybe disable that for your bot because, you want your pirate to curse like a pirate. So maybe that would be a good case of where you might want a Boolean variable, right? Now, we can evaluate this variable, and we can do some interesting things to it. One of those things is called a gate, and we have a few different kinds of gates, and so we're gonna just kind of talk about this one really quick. Then I can show you some of the other gates. So I have a gate here, and I can say, well, if block profanity is true, then maybe I will make a profanity filter node, right? Now go to the profanity filter and do some stuff. Obviously there's got to be more in here, but if it's true, do that. Otherwise, just go generate the text. Don't worry about the profanity filter. And so this gate says, well, either this or that. There are all kinds of gates. There are gates that wait for both conditions to be true at the same time. You might have this has to be true and this has to be true, and then this will be true. So these are in Boolean logic. There are OR gates, either this or that. This is a Boolean gate. This is technically an OR gate. There are also AND gates, this and that. These both must happen for this next thing to happen. And actually, this is all computing, all computers. This is what they're doing under the hood. It's just like lots of this, lots of Boolean gates and different kinds of math, right? So the Boolean gate says, whatever, if true, do that. If false, do that. I'm going to show you a few different kinds of gates that are similar. Is variable true? So the is variable true node is actually the same as the Boolean gate, but we're evaluating something slightly different. What we're evaluating with the is variable true node is, well, we could actually do, if I put the Boolean input into this, it will work the exact same way as a Boolean gate. These would be the same node. The reason we have two nodes, well, we could probably even get rid of the Boolean gate and just roll it into this, because this is more general. This doesn't just handle the Boolean case of true or false. This also handles the case of, well, what if I have a text variable. Where'd it go? Text variable. And that text variable says true. Well, now I can evaluate the word true. And so this is really, really helpful, because what I'm getting back from a large language model or a classifier, or maybe my vector search is like a key value to different to things that could be true or false for profanity or something. A lot of different cases I could use this for. But now I'm checking, did I get the word true, the word false, or did I get the value of true or false? So remember, in the computer, true is 1 and false is 0. If I write the word true, well, that's actually a string, right? That's actually the word true. It's not a 0 in the computer. That's like some crazy thing. That's like a whole bunch of information. So we're using this equivalency, say, well, true equals true. So this node checks for the word true, the value true, and it also checks for 1. If you send in the number 1, it will think, well, that probably means true. In fact, it'll actually take any number that's not 0 and make it true. Any non-zero number tends to be true, 0 tends to be false. So I can say false equals 0. Equivalency between the types. This is not in every programming language, but it's pretty true in Magic that we're trying to give you equivalency. So places where you put true, you can also put like the Boolean there, or less likely, but also possible, you could say make a number variable and make that value 0 and put that in there, and that would be false, or 1 and it would be true. So number 1 is true, is the variable true? Yes, that would return true. Block profanity, well, let's just call this Boolean variable so it's not so confusing. It is checked, it is selected, so that is true, and this text variable is also true. So the is variable true node lets you evaluate and then control your flow. Let's see, we're getting a little crazy here. Maybe I should remove a few things here. Got that. We did all these. We got that one. Okay, so is variable true now has a true and a false. Now, this is a branching logic control flow, which means it branches one way or the other. You can also have things that branch in both directions at the same time, but you don't need a true or false for that. So the two cases you're going to see in your own graphs are, okay, I've got, well, actually, we've already kind of got it, which is this text rule matcher, right? You've got the true or false. It can only go this way or that way. That's one thing you're going to see. But the other thing you're going to see is, well, actually, I want two things to happen at the same time. I want both of these to echo. Okay. Well, that's fine. I mean, let's say, I'll just say condition 1. I'll just say 1. And I'll say 2. I've got a variable for 1. I've got a variable for 2. And I want to combine them. But I have two executions. I want to combine these two nodes, right? Okay. Whoops. And I also want to go search Google for some reason. I don't know why. But that's like a whole asynchronous slow thing. And that might take a while, right? Gotta go search Google. So I want to combine all of these three things. How this one is Google search results, right? And then this one is user typed this in. I've got these variables, but just to go with me on here, I've got some variables and they're echoing. Now I want to combine all this. Okay, well, I have multiple execution flows happening, and they're happening at different times. This echo is instant. This echo is instant. This might take like 2 seconds. And what happens if we start doing these and this hasn't come back yet? Now we've got a real control flow problem. And so this is something that so you have branching logic and you have parallel logic. Those are kinds of the two problems that we're going to be facing and using our nodes to control inside of Magic. So I showed you branching logic. If the variable is true or false, go that way. But what about parallel logic? How do I do all of these three, make sure they've all happened, and then I can go on to doing something else? So for that, we have a node called wait for all. And so wait for all would say, let's take, we have like the header, we have the user input, and we have the Google search, right? So we have three triggers. The wait for all is going to wait for all of them to finish, right? All three of them, and then it will trigger the next node. So we can branch logic out like this, and then we can unbranch it back. And this is a great way so that, if you have to hit your database to do a knowledge search and a Google search and also a long-term memory thing and all these things, you can actually stack them to happen at the exact same time and then return together. And instead of chaining one after another, it will happen a lot faster. So a lot of what I was doing originally before we had a wait for all node was I would chain these, right? And I'd say, okay, well, clearly I've got, to make this work, I trigger that into that, into that, and then I can go to my output, and that works, and that's totally fine. But if these are each slow, like this takes a second, this takes a second, this takes 2 seconds, now that's 4 seconds, right? That took 4 seconds to get through this logic and respond to the user. Way too slow. If I wait for all, and I do this in parallel, and sorry, give me a second, trigger, 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 and then that goes out. If I do this in parallel, let's say this takes 1 second, this takes 1 second, this takes 2 seconds. Now the whole thing only takes 2 seconds. It's only as slow as the longest call, right? The function that took the longest to actually do what it does. So this way, we can really pack a lot of complexity and have multiple things going on, and it doesn't slow your whole graph and agent down, to where it's not conversational. I hope that kind of makes sense. So the key things here are you can pull a trigger out to trigger multiple things, and you don't need any special nodes to do that. Pretty much all triggers can just trigger out to multiple things at once. You can branch logic by evaluating something. Is the variable true, or is the Boolean gate, whatever. And then you can split the or branch the logic to one of two things, not both, but only one of them, using these kinds of true or false control flow nodes. So I'm going to show you a few other control flow nodes that I think will help, and I think then we can kind of wrap it up and maybe take a little Q&A and make sure that we've properly downloaded these pretty complex new concepts. So we've covered the Boolean gate, and the Boolean gate takes a true or false and from a Boolean and returns a trigger, true or false. And in many ways, what this is doing is converting a Boolean value to a trigger, which trigger you want. Another one we have is variable true, as we covered, and it does basically the same thing, but it has a more open socket, and it lets you evaluate different kinds of true or false statements, including 0 and 1, true and false strings, and true and false Booleans. Another one that we have that we've seen before and we use quite a lot is the exclusive gate. So I showed this to you because we use it for some of the templates, like the Discord bot. And what we're using it for there is, well, what happens if you get an input from the voice instead of the chat? We want both of them to be kind of routed through the same graph. And so this is a different way of handling parallel execution. So here you see we're waiting for all of them. These all have to return before the wait for all will then go and pass on to the output. With the exclusive gate, let's say I have input 1 and input 2. Whichever trigger hits first is the one that gets passed to the output. So a really common use of this currently is, let's say I have this input, and I'll make a new input for Discord. Maybe I have a Discord voice and a Discord text input, right? They're different inputs. And I want them to both go into this D structure right here, right? But the problem is that the D structure won't know which of these events to take information from. Can I jam both of them in there? No. You see how I can only send one event in? Oh, that's a problem. So I want the first one. I want the one that actually has data on it, that actually got called, to then pass along. So the exclusive gate will let me take data from this and the data from this. Whichever one triggers, whichever one is calling this purple slot and actually moving data along, then gets sent into the next node. So it's a different kind of gate, right? It performs the same function of some of these other gates, and you could even use this gate to do the same thing here, but it would be very complicated. You have to have a whole bunch of gates and evaluators. This just says, hey, whichever one comes in first is the one that we pass on. I hope that makes sense. So there's a question of, are some of these rule matchers case sensitive? Currently they are case sensitive, but I was actually about to write a GitHub issue for that right before this, where I think that we should have a checkbox for case sensitive, because there's a lot of cases where obviously not being case sensitive would just make things a lot easier for you, especially like a text replacer or anything like that. So that's definitely something that we'll prioritize, because it's a really easy win. So is null or, well, let's talk about that in a second, actually. Let's get through the gates, and then we're going to talk about null, because null is probably the last place to end this. Or gate. Similar to the exclusive gate, it actually does almost the same thing. The difference is that the OR gate triggers when one of these are triggered. and it doesn't pass any data through. So there's no exclusion process here. It just says, well, if either of these conditions happens, fire the next thing. So what kind of conditions could happen? Well, you could say, okay, I've got a variable for I don't know, let's say block profanity, and I've got another variable for is educational or is app for kids. And these are both public variables that are like exposed to your agent, for example. Okay. And then I might have a, well, I guess I could just do a Boolean gate in that case. What's a better example? Maybe I won't do that. I could feed both of these in, but that's actually going to be a pain. I think a better one would be like this, the OR gate here, right? Where I could say, okay, either this happens or that happens for various reasons. I don't know, and then we will pass on the trigger to the next thing. The problem here is that it's just passing on the trigger, so I tend to use like the exclusive gate in those cases. This is why we made it, is because it passes on the data. But the useful thing here is that if you had some complex case where you have like a bunch of evaluations, maybe we will use like, is the app for kids? And then maybe we have a Boolean gate. And if it is for kids, we will trigger true. And then maybe for false, we don't even have to trigger anything, right? It would only trigger on true. And then that OR gate combines with this one. And then if either of these are true, continue on. Hope that kind of makes sense. You could imagine where this is really, again, about recombining parallel flow into a single flow. So things branch out, they get handled by a bunch of different nodes. Whichever one return, if any of them return at all and happen, then they come to the OR gate and you output. A similar concept is the switch gate, or the switch. It's not a gate, but it's very similar to a gate. And a switch is a common programming concept. You'll see this in all programming languages. And the way a switch works is, well, let's go down here. Like, it looks like this. And you have some cases. And one of your cases might be Apple. And you would do some stuff. Right? Another case might be banana. And you might do other stuff. So this is what a switch does. You give it some input, and maybe my input is, hey, my input's Apple, right? I just type in Apple into my console, and then it takes that input, says, oh, you wrote Apple, and it calls do stuff. So the switch in here, we give it some cases. And so maybe I'll give it the case Apple, and I'll give it the case banana. And whatever I input is what it's going to evaluate and then trigger as long as it matches Apple and banana. Now these are case sensitive, and usually, like, what I do is I would do like a large language model prompt that says here are the cases. It might be like greeting, conversation, special knowledge. I don't know. I might have some like labels, and then whichever one gets labeled is like the control logic that I'll handle. So maybe I'll make this a little more real. This is a very useful node for sure. I'm going to trigger it. I'm going to take the content, and if it says Apple, I am going to say I love apples. And if the actually I want that note, don't I? If it is banana, we'll say I love bananas, and then we'll have one more, which is I don't recognize that. Okay, we've got three kind of variables. We will make echoes, So for the apple case, I have my apple. For the banana case, oops, I have my banana. And then for the default case, the echo, I have the, I don't recognize that. And then we'll just put those into our output. So the default comes by default. And the way the default works is if it doesn't match apple or banana, it's going to fire the default, right? That's the one by default, switch to default. Otherwise, oh, you have apple case. Okay, do the apple case or the banana case. So great, type testing. I don't recognize testing. How about apple? I love apples. So it's evaluating the input, switching based on the word apple to echo I love apples. If I say banana, you can see it's firing the echo for banana and saying I love bananas. And if I say tire, it says I don't recognize that. So you will have to do some formatting here, like make sure that you're only giving it exactly what it wants. But that should be useful for like classification and some of the basic stuff we do in here. Okay, let's see. We went over. We have a couple more gates. This is kind of a fun one. You take in a trigger, and you can add a bunch of outputs. Okie dokie. And you could imagine, let's say you had a collection of different greetings, like, hey, hello, how are you? You could just like randomly choose one of them, for example. Or you had a collection of behaviors, or like, you know, your pet has 5 things it can choose to do, and you want to randomly choose one. This is the random gate, lets you choose randomly and trigger one of the paths you want. So you could imagine, for example, let's do this in practice. Instead of this switch, let's randomly trigger one. So it's almost the same as the switch in terms of layout, right? But we're not evaluating anything. We're just randomly triggering one. And I will reset this and say testing. I don't recognize that. I love apples. I love apples. I don't recognize that. No bananas? I love bananas. There you go. So it's randomly switching between these triggers. I hope that makes sense. You know what would be great? We should add this. We should just make a text transform node that just takes all your text in lower cases or upper cases. Then it would be really easy to do like a lowercase evaluator or something. For somebody put it on the backlog. Okay, so we've covered these. Now we got one more kind of idea to talk about. And this will also, we'll bring this into our equivalency. You might see this word null. And you might also see the word undefined. So null is sort of a philosophical concept of nothing, right? It's not zero, but it's the absence of zero. And so null is like emptiness, you know? And it's a very useful concept because it's saying, hey, we're allocating. We're saying this is gonna be a thing, but it's not right now. Or, hey, I gave you back something. It just happens to be nothing, right? So that's the idea of null. And null does not exist in every programming language, but it exists in most of them, especially the ones that we use. And the idea of null is, well, null is not equal 0, except, but the crazy thing, but it's got some interesting cases. Null is not 0, right? And it is defined, which means we have set it to something. It just happens to be something that we set it to means nothing, right? Null equals null. It's null. There's another case, especially in JavaScript, of undefined. And undefined says, well, you didn't even set it to null. You didn't set it to anything. You didn't even define that value. So sometimes in JavaScript especially, which is the language that builds all of this, you can have things return as undefined or as null. We tend to treat them in a similar way, especially in Magic. We kind of combine the concepts, and we call it null or undefined, right? So sometimes, let's say you search Google. Well, it's gonna bring you back something. What's a better one? I don't even know. I don't really know where you would. I can't think of a simple example, but let's say you did search Google and it just didn't bring back anything. It failed, right? Instead of bringing back a summary, it actually just totally failed, and it's just like, nah, it didn't even work. Like Google blocked the API, whatever it is. Well, then you might want to check. Well, did it give me back anything? Where I really use this a lot is when I'm writing in the code node, and I actually have some code in here, and I'm like, doing some crazy stuff, or if I'm using, like, I'm doing a web request with a request. Sometimes I need to check if it came back with anything, and so this is null or undefined. It's very similar to the other evaluations. The is variable true, as well as the no, which one was it? Well, yeah, I mean, it's kind of the opposite here of the is variable true in a way, right? It's got the same layout, but it's checking for a different kind of value. If the thing did not return, or it's undefined, or you set up some whole deal and it just never came back with an answer or something, then you can fire true or false from there. Now, one other point on null. In JavaScript, null equals false. It's a weird thing. Oh, also something to know, this double equals that means that this equals this. That's what I'm saying here. It's a comparison operator. And this means doesn't equal this. It's right. So null does not equal 0. Null does equal null. And null equals false. I know this is pretty abstract. This is kind of programmery. But it's good to know. You probably hear these words sometimes, and you're like, what the hell is null? Like, what is a string? And I hope that this kind of helps to illuminate some of that for you. So we've gone over most of the nodes that I wanted to go over. We did the wait for all. We did the null or undefined. Let's just make sure we kind of got everything in here. We went over control flow. One of the core functions of Magic is enabling you to evaluate conditions and make decisions. This is a huge part of what we do is control flow. And we've kind of hidden that because it's sort of complex and gets into the more programmy part of Magic. But now that we've sort of, in week 5, we're starting to get into that. I think we added all of this. I'd love to show you something very simple that we can use some of this for. Let me show you what I'm working on and what we're going to be kind of getting into. So this is ELIZA. It's a pretty complex graph. A lot of this will be simplified or abstracted or moved into smaller graphs. But right now, what's really happening is I'm taking some input, and then I'm evaluating that input for a rule match. And the match that you see this add intent. So if I type in /add intent, it will match this rule. And what it does is it takes whatever I wrote, it removes the, I gotta make sure that's right there. It'll actually remove the /add intent from whatever I wrote in. It'll create an embedding of the content minus the /add intent, and then it will store that as a document, store document. We haven't gotten into documents too much. We're gonna get into this next week because it's super useful for all kinds of problems you want to solve. But we've had to sort of refactor a lot of it, and so that'll be coming next week. But the idea of a document is I want to store some intent and just store it somewhere. So I can type /add intent, and then I can say it's a task intent, and maybe it's can you check my email and summarize any new or interesting ones for me. And then it says, cool, added document. And you can see it shows me what the document is. It actually removed the /add intent from the document. So now I've stored that intent. And so now I don't have to, I have an interface to do this in the UI, but I can also add new things from my agent, just directly talking to my agent. I could also say hello, and the agent responds with hello. How are you doing? Oh, it seems to just be echoing right now. There's probably a reason for that. I forget why. Or it's on a long-running task. I'll have to look at that. But the idea is that if it doesn't match, it can go into like my chat GPT mode. If it does match, it can start doing these kinds of like admin commands kind of thing, right? So you could have like a digital pet that you could talk to and communicate with, but then you could also have like /feed/pet, all that with this like text rule matcher and all of this stuff. The rest of this is basically everything you've seen before of recalling long-term memory, doing some evaluation, more of that document stuff. And then we're going to be going over this new thing next time. So next week, we're going to be talking about tasks. We're going to be talking about documents. And this is going to be the beginning of where this stuff gets really, really interesting. Because we're going into full autonomous agents. And so this task input will allow us to create looped tasks that the agent can do for a long time. Like, go search the first 1,000 pages of Google and get me everything about elephants from every single response, and then deduplicate it. Like, that's the kind of thing I want, right? Or go through my entire Discord and find all instances of YouTube playlists and give me a list of all of them because I'm looking for a couple that I can't find. And so this task abstraction will allow us to run really complex reasoning tasks and make agents that can do complex long-running things. So that's what we're going to get into next week. I hope this was helpful, and I'm going to switch over to the chat. If you guys have any questions about the stuff we covered today, I know it was a lot, and this will be recorded so we can go over it again. Yeah, now's the time. And I will just wait here silently for 5 minutes while you guys type it out if you have anything. I'm very curious if any of you guys are working on cool stuff. I was very impressed by the graphs that Captain Bacon, who's one of our new alpha users, was working on. It's very interesting. Please post any graphs if you guys are working on stuff in the development channel or anywhere. It's really great to see. And if I can help you with any of the problems you're having, or like, there's user experience things that that you identify that you need changed, please let us know. A couple of our engineers are kind of out ahead working on this AGI stuff, autonomous agents. And then a couple of us are, just making sure that you guys are supported and all the bugs are getting fixed. So I have a question for what is the use of the array remap node? This is some advanced stuff. What is an array? First, let's talk about what an array is. So sometimes you have a number like that, and that's cool. But what happens if you need to give me like 3 numbers? Like, I need to know the VIN of your car, and I need to know the year of your car. And I also need to know when you bought it. You bought it, right? So there's ways to store that in what's called an object. But especially in the old school programming, you might store that in an array. An array is just a list, basically. It could be numbers, strings, text, images, it could be anything. So in this case, the array might look like, and then the year is like 1990, and then the year I bought it is like 2013. That's an array, right? It's in JavaScript, it's an array in most languages because it's got these kind of square braces. And you can see that there's values in here. There's multiple values. There's the first value, the second value, and the third value. And these values can be pulled out by what's called their index. In JavaScript, the first element of an array is the 0 index, and this is the first index, and this is the second index. So if I want to get VIN, let's say I say array equals that, right? VIN equals array 0. I know this is crazy looking, but get the 0 element, the first thing that's in that array, just get that value, and that's the VIN. This is the programmery version. It's a little complicated. So sometimes we want to get only certain things out of the array, or we want to interact with the array. And usually the kinds of arrays we might get aren't so simple. They're usually something like const search results equals, and I have a whole bunch of things like link google.com, whatever, description, search for stuff. So that's one array element. That's the array 0 of the search results. And then I also have like, I don't know, apple.com, buy cool computers, right? So now I've gotten some search results. I only want some of the information in this array. I don't actually need the description. I just want the links. So how do I get this array to turn into the array that I want? Well, there's a code way to do it, and that would be search results dot map, and then results, and then I return link result dot link. Okay, cool. I've remapped it now. I only have the link here, right? This link, and I've gotten rid of the description. But that's not going to work for Magic. That's super confusing. This is like way hard mode. So what's the simple version of this? What's the visual version? So let's say I get a Google search here, and it gives me, well, no, actually, let's say that I get a bunch of events. We actually use this all the time. And this events, this blue, indicates an array. There's an array here. And now I don't want all of the event information. I just want what people said. I just want like the content of the event. Remember, the event looks like this. There's a content field. There's a bunch of other fields. I don't care about any of these. I just want that content. But I want it for all of the things in the array. All of the events, every conversation. So I have a remap array node that takes an event and it takes some values. And these values are separated by a comma. What value do I want? I want content. What else do I want? I also want sender. So I'll add a sender there. So now this whole array of events, which has all this crazy information, actually will now only output an array containing content and sender. So this array that comes out is like just part of this array. Just give me the values of this array that I need. So I hope I don't really want to set the whole example. It's kind of complicated, and this might be a little hard mode for you guys. But that's kind of the concept of how the remap array works here. And we can use that a lot for then bringing information back to our LLM, or I just need some of the information and I want to make it easy to print out to the console. I don't need all of it. That's where I use that a lot. Any other questions? So there's a question on how do we sort of interact with the real world? Obviously, we have connectors here to some of the different places you can go, but you might want to do things that are outside of the box on that. A few ways you could do that. One is the where do it be? The request node. The request node is a little complicated, but it lets you serve an HTTP request to a website. You type in any headers you need. You might need some like authorization or cores or whatever. You type in some inputs for the body. This would be like the data that goes into the request. You type in where, like google.com, and then something like post or get, the post method. This should be a dropdown. But that's pretty hard mode. It gives you back the whole request object. You can parse that with a code node or some of the get value from object stuff, like get value from object. But it's not great. This is, it's a pretty, it's too low level. So the thing we want to add is a Puppeteer connector. We had this for a while and we just disabled it, but we'll bring this back, especially if there's interest. Puppeteer is a Google thing, kind of. You can see it here. It's a Node.js API, but basically what it is just Chrome. There's a bunch of information about it here if you're curious. So we can automate Puppeteer to start up a task and like go visit a website, scrape the website, do whatever. I've done a lot of automation and puppeteering outside of this. The reason we haven't included it in Magic yet is because it's a fairly memory intensive for the cloud, and so we have to just make sure that we can scale that before we can offer it. But you will pretty soon be able to have Puppeteer as a connector, so you can have like go visit a website, get the current website, change the website to a different website, find every link on the website, and that'll be something we're working on pretty soon because that's very useful for our autonomous agents track. But yeah, basically the limitations are that while I had that running on my own computer and it was kind of cool, it is non-trivial because each instance is like a gigabyte, so we have to make sure that all of our scaling is done first. Yeah, so the requests are a way to access any REST API. Another thing that you can do is if you go into the agents view and you enable our REST API, you can use Magic as a backend for like a front-end app, a Vercel app. And you can go into like the post example and you just copy this, and this is like the JavaScript code you need to call your spell or your agent here. We should go over that maybe next time. That's super useful. And we could probably even, maybe that won't be next time, but maybe the time after. I'd really love to show something we're going to work on is like a template that has all of this worked out, so you could just like deploy an app to, the web basically with a little template, and then plug in your API key and agent ID, and then all your backend would be done. So if you want your own like ChatGPT with your own app or personality or whatever, we'll work on that. The Puppeteer cannot currently be run locally because the connector has been just kind of deprecated, and I have to remake that a little bit. But if that's a priority and something that you're going to use, then we can definitely prioritize that in the next few weeks. I think that, it's going to be really crazy when the autonomous agent can go browse the web and like surf the internet. That's where things get really interesting. It's going to be hitting you up for captchas all the time. Like, why am I filling out a captcha for this website? I don't even want to know. Anyway, kidding. Cool. Anything else, guys? So currently what I'm working on as fast as I possibly can, and I think Mike is flying, but he's also helping with this, is a fully autonomous agent. And instead of having to create your entire crazy skill graph, we're going to make it so you can just make skills, pile them in to the autonomous agent template that we provide. You can kind of skip like 90% of this complexity and then just focus on the things that you care about. Like, I want a skill to check my email and summarize all of the new emails, right? I want a skill that can do a deep search on the web for me. I want a skill that can like find all of the papers on archive.org or whatever. I can think of like a million cool skills, and I'm sure you guys have your own, and maybe we can start to build a skill library. And that's kind of how we get to bootstrapping this agentic thing, which eventually becomes training data for a model, which becomes AGI. So that's where we're going. I think we'll talk more about what that looks like in the next couple of weeks. We're still building it. This task thing is obviously super important to that. So the idea of skills is if I recognize, well, I don't know, you guys know Alexa. Hey, Alexa, can you do this? So when you ask Alexa to do something, that's called an intent. And when Alexa recognizes your intent, it loads what's called a skill. And we're basically just doing the same thing, but with like a big magic wand of AI that helps us to do that intent and skill stuff. So what I'm working on research-wise right now is, can I formulate intent recognition as a search problem? We already have vector search. Can we basically create a collection of intents that describes how a user would interact with our system and then cluster those into kind of a classifier? I think so. I think I'm going to have this worked out in the next couple of days. So once I've recognized what you're trying to do, now I need to loop through, reason about it, get from my skills the ones that are useful for performing the task that you asked me to do, execute them, and then reflect on whether I did it well or not. And that is the like bootstrapped autonomous agent loop, which if you've seen Agent GPT or Auto GPT or Baby AGI, they're all doing this, but they don't have a full skill abstraction. They have a tool abstraction. And that means it has the ability to search the web, but it doesn't really know how to search the web, if that makes sense. It doesn't have any of the framework and support and stuff that we're adding. So that's what we're doing with skills. So a skill is going to be input, does a thing, output, but it also has like a clear description of how you would use it, how the agent would use it, and when to use it. And that gives it the ability to reason through a problem, identify the most likely skills to execute that problem. If there are none that are likely, tell the user, hey, I actually don't know how to do that yet, which we could then try and attempt or have the user, make a report and ask for. You can imagine, and then if they can, execute that task until it's done, and then return the results. The eternal loop of doom. Well, there's a couple of ways. One is that we're doing a lot more on each loop. We're actually performing a specific skill, identifying the outcome, and then failing the tasks and reporting to the user if we fail, because it's not fully autonomous. It's mostly running tasks in response to user input. Hey, can you check my email for me, for example? And so that has some pretty clear pass and fail conditions. And the other thing is that if we find, I have to add this, but we will just do a straight up repeat check. And if we find that the agent is repeating parts of its task, like its reasoning loop more than twice, it's probably in a loop of death, and we have to return to and say I wasn't able to perform that. So our goal right now is not to make an AGI that performs every task every time, but if it performed it 40% of the time and then told us when it was successful or not, we could have a training set that could very well quickly get us to 90%, which could then get us to 98%. So I hope that kind of makes sense. We'll go into more with, like, I'm still building it. Need a couple more days, but I think in the next couple of weeks we'll be showing you guys that stuff. Good deal. Anything else? I think we've gone on pretty long. 84-minute session. Thank you guys so much for joining, and I hope you got a lot out of this. We're here for you. If you have any questions or anything we can help you to move along on, please let us know, and we'll prioritize it. And that's it. I hope you guys have a good day.